Hello and welcome to another video from Cracking the Cryptic. This puzzle is slightly different, it's in more of a crossword style, but I hope that it will appeal to those of you that enjoy Japanese style puzzles because much of the logic is very similar, but perhaps with a wider array of different and interesting techniques. So the grid is as shown on the screen now, and if I scroll down you can see that there are some instructions. Let's have a look at those. So across entries are labelled by capital letters and down ones by italic lowercase, and you can see that in the grid above, the big letters indicating the across entries and small italic letters, the down entries. All entries, including the unclued ones, are different, and none starts with 0. That's absolutely standard for this kind of puzzle. It does mention unclued entries, so let's just have a quick look at the grid. And you can see that this entry here is unclued. This capital J refers to this 3-digit across entry, but this 2-digit down entry doesn't have a letter. And also this 2-digit entry doesn't have a letter either, although it does have a star, which is mentioned in the instructions later. And the instructions continue that multiples and factors are all non-trivial, so not multiplying or dividing by 1, again, fairly standard. And just to save a bit of time on the video, I'll just mention that the rest of the instructions aren't necessary for the purposes of filling the grid, so we'll just skip those for now. And if I scroll down, you can have a look at the clues themselves, and you can see that the clues, split into across and down as normal, are all clues which refer to other clues or other mathematical properties or numerical properties of the numbers, whether that's palindromes, triangular numbers, or in the case of this example, simply an arithmetical operation or operations on other entries in the grid. So we're going to use these clues to fill the grid. Okay, I've moved the webcam to the top right of the screen, which hopefully means that the clues are now all visible to you. On the left of the screen, I've got the grid at the top, and I've got a little scratch pad at the bottom that I'll just use for making a few notes when needed. Now, with a puzzle like this, what I tend to do is just skim through the clues and look for anything that jumps out. And one of the things that I'm looking for in particular is any high powers that are in the clues. And the reason for that is that whereas multiples go up linearly, powers go up exponentially. And what that means is that for any given entry length, there are likely to be many fewer options where a high power is involved. So for example, in this puzzle, we can see that little w, or w down, is a 4th power. Now it can't be 1 to the power 4, because that would only be 1. And it can't be 4 to the power 4 because that's 256 and much too high. So it must be either 2 to the power 4, which is 16, or 3 to the power 4, which is 81. So this entry here must be 16 or 81. Now, that's interesting because that entry also comprises the last 2 cells of big T across and big W across. And if we look at the clue for big W, we can see that big W is big X minus big T. So big X minus big T is W. But what that means is that X equals T plus W. Well, we know the last digits of T and W are either 1 and 6 or 8 and 1, and that means that the last digit of X must be either 1 plus 6, which is 7, or 8 plus 1, 9. So this digit here must be either a 7 or a 9. But if we look at the clue for X, big X, we can see that it's a palindrome, which means that this entry here must be either 77 or 99. Now, if it was 77, then this digit here would have to be a 7. And now we can look at the clue for little x down. Little x down is a square. Now, as it happens, there are no square numbers that end in 7, and you can see that by squaring the digits between 0 and 9 and noting that none of those end in 7, therefore no square can end in a 7. That means that big X across can't be 77, so it must be 99. And that means that W down can't be 16, it must be 81, so that big T plus big W has an answer that ends in a 9. So we can put 81 in for the answer to W down. Now in the clues, when I've solved a clue and it can't give me any more information, I'm going to just highlight it like that. And I can do the same for W down, which we know is a 4th power. There's no more information to be gleaned from that clue. And I can also delete that from my scratch pad. Now, little x down is now a square ending in a 9, but there are only 2 of those less than 100. One is 9, which is too small, and the other is 49, and that must be the answer. So that's a 4, and we can't do anything more with this clue. Now, we can also see that capital U across, is a palindrome as well. And because the first digit of that is a 4, so must the second digit be. So capital U across is 44, and we can tick off that clue. And now, looking at little s down, we know that two of those digits are 4 and 9. It's something 4, 9. But the clue for little s down is 9 times big S, which is a 2-digit entry. Well, if a number is divisible by 9, then its digit sum must be divisible by 9. That's a similar result to the one for 3, which most people know. And 9 plus 4 is 13, which means that if this 3-digit number is divisible by 9, its digit sum must be 18, and therefore this cell must be a 5. And that also means that big S must be 1/6 of that, which is 61. So we can put 61 in at big S. Now, we didn't look at the clue for big S there, so let's do that. It just says it's a prime, and 61 is indeed a prime. So that's all okay. We can tick off that clue, and we can also tick off the clue for little s. Now, looking at capital Q, we're told that Q is a triangular number. Now, the triangular numbers, if you don't know what they are, worth a quick Google. I'll just list the first few. They are 1, 3, 6, 10, 15, 21, 28, 36, 45, 55, and 66. And I'm going to leave those in the scratch pad because we'll need those again later. But you can see that only one of those begins with a 5, and that's 55. So capital Q must be 55. So we can put a 5 in there and tick off that clue. Now we can also look at the clue for little v down, which has 1 as its first digit, and we're told that that's a square. Well, there's only one square that's 2 digits, with the first digit being a 1. That's 4 squared, which is 16, so that entry must be 16. Now, we can't cross off the clue for little v yet, because you'll see that it refers to big H, and big H is twice the sum of the 76 digits in the grid, so that's not something we can look at just yet. So I'm going to highlight only the part that we solved, which is the square part, and leave the rest for now. Now, the next little step is really quite interesting. Everything so far has been fairly routine for this kind of puzzle, but the next step is something really quite nice. Let's have a look at little n down. We're told that little n down is a multiple of little x, and we know that little x is 49. Well, the only possible multiples of 49 that can end in a 5 are 5 times 49, which is 245, or 15 times 49, which is 735, and everything else is too big. So it's one of these two. But now let's look at capital A across. We're told that capital A is little n minus big K. Now the answer to that has to be positive, and that means that little n has to be bigger than big K. Big K is an anagram of little n. So if little n were 245, we've got a problem, because 245 is the smallest possible value from anagramming those digits. So that means that big K couldn't be smaller than n, and therefore big A across would have to be negative. So that isn't a possibility. So we can cancel 245, and we're left just with 735 as the only possible solution to little n down. And we know that big K is now an anagram of those 3 digits. So we can cross off the clue for little n because that's a multiple of x. We can't say anything more about that. And now let's jump back to big T across and look at the clue there. The clue is divisible by its digit sum. Big T is a 2-digit number ending in an 8, which means, for example, if it were 18, its digit sum would be 1 plus 8. 18 is divisible by 1 plus 8, which is 9, and therefore 18 is a possibility. But 28 wouldn't work because 2 plus 8 is 10, and 28 isn't divisible by 10. Checking quickly the other options, you'll see that the only other possibility is 48, which is divisible by 12, and that means that this cell here is either a 1 or a 4. Now that's interesting because little q down has its digits in ascending order. So if this is at most 4, the first digit here can't be any more than that. It's not completely clear whether it could be a repeat digit, but let's not worry about that for now. Certainly it's only 1, 2, 3, or possibly 4. Now, looking at the clue for big N, which also crosses that cell, we can see that big N is a prime. But if big N is a prime and it's 2 digits, it must be odd, which means that this cell here can now only be a 1 or a 3. Moreover, we're told that big N has the same digit sum as big Q, which is 55. So therefore, its digit sum is 10. That means that we know that N is equal to something 1 or something 3, and has a digit sum of 10, which means it has to be either 91, which is 7 times 13, therefore not prime, or 73. And 73 is prime, which means that 73 is the only possibility for capital N across, and we can put that in there. And that's also that whole clue dealt with now, so I can tick that one off. We've just used big Q a couple of times, and we're going to use it a couple more times now with some really nice logic coming up. First of all, let's look at big E, which is big Q times little u minus 5 times big B. Well, 5b has clearly got factor 5, and because big Q is 55, that term there also has factor 5, which means that big E itself must be divisible by 5. So it ends in either a 5 or a 0, but it can't end in a 0 because the last digit of big E is the first digit of a down answer. So that cell there must be a 5. Now that cell there is the first digit of little k, and little k is a prime containing a repeated digit. If this contains a repeated digit, it can only be 557 or 577. Now, I've no idea whether those numbers are prime, but I do know that this cell now can only be a 5 or a 7, and that's interesting because of the clue for a big J across. Big J across is little v plus a cube. Now, earlier we looked at a fourth power. There aren't very many cubes between 100 and 1,000 either, or slightly less than 100. So let's list those. There's 64, which is 4 cubed, 125, 5 cubed, then 216, 343, 512, and 729. And then, of course, 10 cubed is 1,000. But we know that little v is 16. So if big J is little v plus a cube, we can add 16 onto these numbers and immediately see that that one is too small. Then we've got 141, 232, 359, 528, and 745. So those 5 solutions there are the only options for capital J across. But a moment ago we said that this cell here had to be a 5 or a 7, so that little k has a repeated digit. And the only one of these numbers that has a 5 or a 7 in the middle is 359. So that means that big J has to be 359. So I'm going to cross off the clue for big J. And I'm also going to cross off some of the clue for little k. I'm going to cross off the bit that says containing a repeated digit, because it now does. I'm not going to cross off the prime because I don't know that 557 is prime, and that's something I'll check at the end of the puzzle. Now, we haven't quite finished with big Q yet because there's one more clue that involves it, and that's little d down. 2 times big Q times little n plus little a. Well, if big Q is 55, then 2 times big Q must have a factor of 10, which means that this first term here must end in a 0. And that's important because it means that little d and little a must end in the same digit. So this cell here and this cell here must be the same. Let's have a look at the clue for little a. Its digit product is 0. Well, that's only possible if one of its digits is 0, one or more of its digits, I should say. But looking at little a down, its first digit can't be 0 because no entry starts with a 0. If its last digit was 0, then we've just discovered that the last digit of d, little d down, must also be 0. But that means that the middle digit of big K would be 0. But we know that big K is an anagram of n, and n is 735. So that means that this cell here must be a 3, a 5, or a 7. So that cell there must be a 3, a 5, or a 7, and therefore the 0 in little a down can only go in the middle. Now we can do a little bit more with little a because we can see that little m is a multiple of little a. But we also know that big K is an anagram of little n, which is 735, which means that these 3 digits here are 7, 3, and 5 in some order. And in particular, this cell here has to be a 3, a 5, or a 7. Now, let's suppose for a moment that the 7 goes in that cell just there. Well, what that means is that this cell would have to be the 3 or the 5, but we know from our previous deductions that little d down ends in the same digit as little a down. So if this digit is a 7 and this one is the 3 or the 5, then this one must also be the 3 or the 5. Let's suppose it were the 5, which is the higher of the 2. Well, because a down is now a 3-digit number ending in 0, 5, that means its multiples go up such that the last two digits of those multiples will be the same as the multiples of 5. So there'll be 0, 5, 1, 0, 1, 5, 2, 0, and so on. But because A down is 3 digits and so is M down, and M is a multiple of A, it can't be a multiple of more than 9. So the maximum that M could be would be 9 times A down, and that would mean that the last two digits were 45. And we can't get any higher than that, and clearly if the last digit of A down were a 3, then the options will be even lower. So actually it's not possible for us to get as high as a 7 for the middle digit of a multiple of little a, which will fit in here. And what that means is that this digit cannot be the 7. But we also know the 7 can't go here, because if it did, k across would have to be at least as big as little n. And I think we can assume that an anagram isn't the same number, so it would have to be 753. But then again, going back to big A across, that would make the answer to that negative. So the 7 can't go first or third in this entry, and so the 7 must go in this cell here. And again, from our earlier deduction, that means that this cell here, which we just said had to be a 3, a 5, or a 7, that can only now be a 7. So little a down is something 0, 7, and big K is either 3, 7, 5 or 5, 7, 3. But we can actually do a bit better than that, and this is a feature of this kind of puzzle. You often have to jump between clues back and forth just to reduce the options, because we know that K is 573 or 375. Let's suppose it were 375. Well then, big A across, which is little n minus big K, would be 735 minus 375. Now I'm not going to work that out accurately, but it's roughly 300 or 400, and that means that little a down would have to be 307 or 407. So the biggest multiple of that little m down could be will be 3 times it, but 3 times something 07 would have to end in something 21. But then this digit here, which we know is a 5 from K across, is a contradiction, because we've said that the last two digits here can't be any higher than 21. So 375 isn't possible for big K, and the only remaining anagram is 573, which we hope is going to give a sensible answer for the multiple. So we can cross off big K, because that's now an anagram of little n. We can also fill in big A, which is little n minus big K, which is 162, and I can cross off that clue. And now we know exactly what little a down is, and its digit product, as we know, is 0, so I can cross the clue off. And we can also now deduce the exact multiple of little a, which goes in at little m down, because little a is 107, so its last two digits in its multiples go up with the multiples of 7, so 07, 14, 21, 28, and then 35, and that's obviously the one that we need, because the next one will be 42, which means that it must be 5 times little a at little m. 535 is the answer there, and I can cross that one off. Now, before we go any further, I'm just going to do a little bit of tidying from clues that I solved earlier. We've got big T in the grid now. That's divisible by its digit sum, so I can cross that clue off. We also know that big W is big X minus big T. Big X is 99, T is 48, so big W is 51, so I can cross that off. And you can see also that that solves little q, which has its digits in ascending order, so I can cross that one off as well. Now there's some more really nice logic coming up now. We're going to look at little t down, which is big Q times little v plus big V. We know that big Q is 55, we used that several times already. Little v is 16, and 16 times 55 is 880. So little t down is at least 880, and it's 880 plus the value of big V across, which is this 2-digit number here. But we know that big R is a factor of little v. Now the smallest that r can be, because it's a 2-digit number, is 10, and therefore, because factors don't include the number itself, we're told that in the preamble, the instructions, that means that big V is at least 2 times the smallest value of r, which is 10, so big V is at least 20. That means that little t is at least 880 plus 20, which means it's at least 900, and so we can put a 9 in just here. Now, that's very interesting because of this clue here, which is for little p, which says that the mean of little p and little r is t. So this number here and this number here are average out to this number just here. Well, if little t down is 900 and that's the average, what that means is that the other two 3-digit numbers must be such that one of them is a certain value above little t and one of them is a certain value below little t. But if t is at least 900, then the biggest gap there can be is 99. And that's if t is 900 and one of the numbers is 999, in which case the other one would be 801. So 801 is the lowest that either p or r, little p or little r, could be. That's particularly interesting at little p down because it means that this digit here is either an 8 or a 9. But it's also the first digit of big M, which is the across clue, which is itself 2 times little f. Well, little f, we're told, is a triangular number. Now, I've got the triangular numbers down in my scratch pad from earlier, and you can see that if you double the ones that are in the right area, 36 would give you 72, 45 would give you 90, and 55 is clearly more than 100. That means there isn't a triangular number which, when doubled, gives you a 2-digit number and beginning with an 8. So in fact, the only options for little f and big M are 45 for little f and twice that, 90 for big M. So I can cross off the clue for big M and the clue for, at least part of the clue for little f, because we're also told it's a factor of big C, which I'll come back to a little bit later on. And then we can say that the first digit of big C must be a 5 because big C is a palindrome. So that means that this digit is a 5 and little b down is 65. Its clue says that it's not prime, so that doesn't tell us anymore, and I can cross that one off as well. And I think I can now clear everything down here in my scratch pad because I don't think I'm going to need any of that again. We're now going to return to a clue that we looked at a little earlier, which is little d down. Little d down is 2 times big Q times little n plus little a. Well, we now know all of those terms. So little d is 2 times big Q 55 times n, which is 735, plus a, which is 107. Well, 2 times 55 is 110. So that means we can work out that multiple quite easily. 735 times 110, 73500 plus 7350, which is 80850, plus the 107 gives us 80957, and that is the answer for little d down, 80957. So I can cross the clue for little d down off. And I'm going to look back now at something that we deduced earlier, which is that the clue, or the entry for little r down, must begin with an 8 or a 9. That's because of this clue here about the average of little p down and little r down being a little t down. So if little r down begins with an 8 or a 9, that's interesting because of the clue for big P across, which is little q plus little y. Well, little q is 3, 4, 5. So if big P ends in 8, 5 or 9, 5, and y down is 2 digits, then that means that y down can only be 40 or 50. They're the only two possibilities. And therefore, big P must be either 385 or 395. So I can put a 3 in that cell just there. I can also put a 0 in that cell, and this cell must be a 4 or a 5. But we know that big R is a factor of big V. In other words, big V is a multiple of big R. Well, big R ends in a 9. If it were 19, its multiples would be 38, 57. If it were 29, its multiples would be 58, and so on. And if it were 39, then it hasn't got any multiples beginning with a 4 or a 5. Now, the only options there that began with a 4 or a 5 were 57 and 58. So y down must be 50, and that means that big P must be 345 plus 50, 395. So we know that big V across is either 57 if R is 19, or it's 58 if big R is 29. So this cell here is either a 7 or an 8. and we'll just hold that thought for a moment. But let's now look at the clue for little c down, which is a 3-digit entry beginning with a 2, and it's a multiple of x, little x. Little x is 49, so the only possibilities are 5 times 49, which is 245, or 6 times 49, which is 294. So what that means is that this cell here must be either a 4 or a 9. And that's interesting because we know that big C is a palindrome. So there are now only 2 possibilities for big C, 54045, which has a digit sum of 18, and 59095, which has a digit sum of 28. And the digit sum is relevant because big V has a clue which is the digit product of itself plus the digit sum of C. Let's suppose that this cell here were a 7. Then the digit product of V will be 5 times 7, which is 35. And the digit sum of C, in that case, would be, it would be either 18 or 28. And neither of those added to 35 gives you 57. So that doesn't work. And this cell, therefore, must be an 8. Now the digit product of V is 40, which means the digit sum of C would have to be 18. And we see that that is a possibility just there. So that means the digit sum of C is 54045, digit sum 18. That fits the clue for capital V. Digit product is 40 plus the 18 from the digit sum of C. So we can cross off the clue for V because this is now the only option. We also are able to cross off the clue for C, which is now a palindrome. C down must be 5 times little x, which is 245, and big D, which is also a palindrome, must therefore be 495, and we can cross that off. We can cross off the clue for little c, and we can cross off. We can also cross off the clue for little y, which I forgot to cross off earlier. That's not prime. It's 50. And we also now know that because big V is 58, the factor of V, which goes in at big R, must be 29. And we can cross off that clue as well. So we're really rattling through the grid now. I think I can clear out my scratch pad and just fill in a couple of other answers. Firstly, little t is big Q times little v plus big V. We worked that out earlier as 880 plus big V. Well, big V is now 58, which means that little t is 880 plus 58, which is 938. And that tells us a little bit more about little r and little p, which we'll come back to soon. We also know that the digit product of little c is 2 times 4 times 5, which is 40, and little z is a multiple of that, so must be 80. So we can fill that one in too, and we can cross off the clues for little z and also little t, which we've just filled in. Now a clue we haven't looked at yet is the one for little o down, which is the digit product of little r. Now at first glance it looks like that isn't something we can do much with yet because we don't know the second and third digits of little r, but the digit product must include a 9 and therefore little o must have factor 9. Well, a 2-digit number with factor 9 can only be 72, so we can fill that in. And that in turn means that little r must have 3 digits which multiply together to give 72. If one of them is a 9, the other 2 must multiply to give 8, so it can only be 918 or 981 or 924 or 942. Those are the only possibilities. But we're also told that little r has its digits in descending order. So that immediately rules out 918 and it rules out 924. Let's suppose it were 981. Well, then r would be 43 more than little t. And because little t is the mean value of little p and little r, that in turn means that little p would have to be 43 less than little t. But little t is 938, 43 less than that is less than 900, and that isn't possible. So 981 also isn't possible, and therefore the only option for r is 942, which I can put into the grid now, and that fits nicely with the digit product being 72. So I can now cross off the clue for little o, and I can also cross off the clue for little r, and I can now say that because little r is 4 more than little t p must be 4 less than little t, and that therefore must be 934, so that the mean of that and little r is little t, and I can cross off that clue too. Now the next clue of interest is big L, which we're told has a digit sum, which is a Fibonacci number. The Fibonacci numbers, which I'll just jot down here because we'll need them again in a moment, are 1, 2, 3, 5, 8, 13, 21, and we'll need a few more in a moment. But for now, the digit sum of big L is 7 plus 3 plus one more digit. Well, if its digit sum is a Fibonacci number, that means it must be 13. The others just aren't possible, so that digit there must be a 3. We're told it's a prime, and again, I've no idea whether 337 is a prime. That's something I'll check at the end of the puzzle, but for now I will just cross off the bit about its digit sum being a Fibonacci number. Now the next clue of interest is for I down, which is little n plus a Fibonacci number. Well, little n ends in a 5, and the entry at little I ends in a 3, so this Fibonacci number must end in an 8. Of the numbers we've written down so far, the only one that ends in an 8 is 8 itself, and if we continue the sequence, 34, 55, 89, 144, which is the highest square in the Fibonacci series, and that's a way to remember that one, then 233, and the next one will be above 300, and that will be too big to add to little n to give a 3-digit entry. Well, the only number here that ends in an 8 is 8 itself, so that must be the Fibonacci number referred to in the clue for little I. So little I is 735 plus 8, and that's 743. So I'm going to cross off the clue for little I, and I'm also going to cross off the clue for little e, which we know ends in a 5 and therefore cannot be prime. So we can't get anything more from that clue, even though we don't know what little e down is yet. And just looking back a bit, I'm also going to cross off the clue for big P, which I forgot to do earlier. Now looking at the clue for little h, we can see that's a palindrome, so that means its last and first digits are the same, so this digit here is a 9, and again, even though we don't know the middle digit of that entry yet, we can cross off the clue because it doesn't give us any more information. It can't tell us anything about the middle digit. Next we can calculate the entry at big B across, which is little o times its digit sum plus 1. Well, little o is 72, its digit sum is therefore 9. 9 72s are 648, plus the 1 gives us 649, which fortunately fits with the 4 we already have in the grid, and I can cross off that clue. And another clue I can cross off is little f, because we can see that 45 must divide this number. Clearly 45 divides the 45 here, and because 45 times 2 is 90, and 9 divides 54, that means that 45 must divide this whole thing. So little f is a factor of c, and we can cross off that clue. Now, going back to big E, we know that's big Q times little u minus 5 lots of big B, which we now know, and we also know that it's odd. So this term here is odd. What that means is that this term must be even, because we need big E as a whole to be odd. We need it to end in a 5. And so because big Q times little u is even, and because big Q is 55, that means u itself must be even. So little u down must have a 0, 2, 4, 6 or 8 in this cell. Now that's particularly interesting because big F is little u plus 1. So if little u is even, that means big F must be odd. So this cell here must be an odd number. We'll come back to that in a moment, because let's now look at the clue for L down, which goes in just there. That's 1,000 fewer than a triangular number. Now, there are various ways of calculating triangular numbers. I'm not going to go into those now to keep the video a sensible length. I'll just tell you that the relevant triangular numbers are 1653 and 1953. There aren't any other possibilities which will give 1,000 less than that as something that will fit into the entry at L down. So that means L down is 653 or 953, but we've just said that big F has to be odd. So this cell here has to be a 9, and because big F is 1 more than little u, and u begins with a 6, that means that big F is 69 and little u is 68. And I can now cross off the clue for big F. And I can also now solve the clue for big E, which is 55 times little u, which is now 68, minus 5 lots of 649, and I won't go through that calculation, but it comes to 495. And so I can cross off that clue there. I can also cross off the clue for little l, which is 1,000 less than 1953, which is a triangular number. And looking at little j, that has the same product as big A, the same digit product as big A. Well, big A is 162, so its digit product is 12, and that means that little j must be 43 to give it a digit product of 12 as well. Okay, we're getting pretty close now. Looking at little g down, we can see that's one more than another entry, but it's a 3-digit number beginning with a 9. So we're interested in other 3-digit numbers from 899 upwards. And looking around the grid, there are only 5 of those. There's 934 just here, 969 at little h, 953 at little l, 942 at little r, and 938 at little t. So one more than those would change those to 935, 970, 954, 943, and 939. But we know that big G is a factor of the digit product of little g. And you can fairly quickly see that because big G is 54, which is 9 times 6, we need the last 2 digits of little g between them to have a factor of 6. Well, that isn't true of 35 or 70 or 54 or 39, but it is true of 43. The 4 has factor 2 and of course the 3. So 943 gives a digit product of 9 times 12, which is 108, which is 2 times 54. And that is the only possibility for little g. And I can now cross that one off as well. And I can also cross off big G because it says it's non-prime, which it clearly isn't, and factor of the digit product of little g is what we've just done. So I can cross that one off. So we've only got 3 cells left now. We know that big H is a multiple of 16, and we know that from the clue for little v, but it begins with a 7. Well, 5 16s are 80, so 50 16s are 800. So we can work back from that and work out the multiples of big H as being 784, 768, 752, 736, 720, and 704. Now we can immediately cross off 720 because that would give a 0 as the first digit of the unclued entry just there, which isn't allowed according to the instructions. And we can also cross off 768 because we know from the clue for little u that star is less than 68, which is the entry at u. So the first digit can't be an 8, so we can cross that one off. Now, looking at the clue for big H, we're told that that is twice the sum of the 76 digits in the grid. To save you counting, I'll tell you that the digits in the grid that we have so far sum to 364. So we need to add 3 more digits onto that and double it to give a value at H across. So if I halve each of these possibilities for H across, we get 392, 376, 368, and 352. Hopefully I've got those right. So clearly, because we've already got 364, we can't have 352 as the overall sum. And if H across was 736, we'd have to add a 3 and a 6 onto this sum because those are 2 of the digits we haven't included yet, and that would clearly put it above 368. So it can't be that one either. So we can also cross off 368 as the possible digit sum. So that only leaves 2 more possibilities. If it was 784, then we'd add an 8 and a 4 onto 364, which would be 372, 376. That would leave the last digit needing to be 16, which obviously isn't possible. And so the digit sum must be 376, with H across being 752. So that's 7 for 2 of the digits. That takes us up to 371. And that means that the last digit must be a 5 to give an overall sum of 376. We can cross off the clue for H. We can cross off the clue for little u now, which we know is greater than 25, which is the answer at star. And we can also cross off little v, which is a factor of H, which is 16 into 752. So that's the grid filled. And what I really liked about this puzzle was that there was some very nice logic, but very little trial and error. I think that other than a couple of triangular numbers I calculated and one multiplication, I did almost nothing off screen there. And even those you can do very simply in a scratch pad. So very little trial and error, very little calculation, and that makes for a very nice puzzle. And the only thing left to check is that big L and little k are primes. And I've checked those and they are indeed prime. And of course, even that you can do fairly straightforwardly if you like. They're only 3 digits long. But there is a little bit more to this puzzle. If I scroll up and look at the instructions, you'll see that taking the filled grid's digits in row order, each pair yields a letter as the remainder when divided by the entry at star. Well, the entry at star is 25. So, for example, the first 2 digits in the grid are 16. So that's just itself, 16. The next digit is 2 and then an 8. So 28 divided by 25 is 1 remainder 3. So the first 2 digits yield 16, the next 2 yield 3, then we have 64, which is 14 more than 50. So the answer to that part is 14, and we can continue in a similar vein. Now, it then says that we have to convert those into letters. So that would give us 16, 3, 14 will be P, C, N. Well, that isn't looking great. However, if we read on, it then says that the full letter sequence includes words of length 3, 6, 11 and 9. Well, that isn't the full grid, so maybe some of the cells are unused. Again, to save some calculation, I'm just going to flick to Excel and show you how I've calculated this. Okay, so to finish off this puzzle then, we've got the grid on the left and an Excel sheet on the right. In column B of this sheet, I've transcribed the digits from the grid, so 1, 6, 1, 6, 2, 8, becomes 28, and so on. And at the end of row 1, we have a 9, and then we go back to the start of row 2 for a 0, that gives a 90 here, and so on. In column C, I'm calculating the remainders when those values are divided by the value in this cell up here, which I've set to be 100. And of course, because all the pairs are less than 100, the remainders when divided by 100 are just the numbers themselves. But if I change this to 25, then you'll see the remainders that we started calculating a moment ago. So 16, 3, 14 in the top row, for example. And if I pull out column D, you'll see the result if I convert those to letters using A equals 1 and so on. PCN is what we worked out a moment ago. Now, if I scroll down, you'll see an interesting string of letters just here, H, I, G, H, and so on. That gives us highlighted. So I'm just going to highlight those letters there. And a little bit higher up, we've got digits, which I can highlight. And a bit higher up again, we're looking for a 3-letter word here. We've got ODD, which gives odd. That looks better than NOD for nod. And then according to the preamble, there was also a 9-letter word. But we've only got 11 letters left now. And the middle 9 of those spell Nishikado. And I'll explain in a minute what that means. So we've got odd digits highlighted Nishikado. So if I go back to the grid and I highlight all the odd digits, this is what I get. Now, a bit like an impressionist painting, you might need to step back a little bit from this to see what it is. But if you do, you can see that first of all, it's symmetrical, which looks really good. That confirms that we've probably got the right answer here. To find out what this means, though, we need to do a little bit of Googling, and I'm going to Google this name here, Nishikado. And if I do Google Nishikado, you'll see that the first hit is Tomohiro Nishikado. He was a Japanese video game developer and he created Space Invaders. And if we go to Space Invaders, you will see that if I scroll down, you can see some pixelated characters just here. And I'm going to find a close-up of one of those characters. And that looks like this, which you can see is very similar to what we had in the grid a moment ago. And there they are side by side. And the pixelation, if you do check it, is perfect, which really confirms that we've got the grid right as well, or at least we've got odd and even digits right. Hopefully I haven't made a mistake anywhere. And just going back to the instructions one last time, we can see that we need to enter the theme, 13 letters, 2 words under the grid. So Space Invaders is the final part of this puzzle, and that goes under the grid just there. Now, if you haven't come across Space Invaders before, I definitely recommend Googling that. I'm going to claim that I'm just young enough that I don't remember it. But anyway, I hope that you enjoyed the puzzle, and see you next time.